Thank you for your presentation. Good afternoon. My name is Cintrano. I am a PhD student from University of Malaga. My research is mainly about the smart city problems, focused especially in mobility problems as the problem that I will present. That this is the traffic light optimization problem. And in this talk, we will present a new algorithm to solve this problem. This algorithm has the characteristics that we need not only that this algorithm have to find the best of the optimal solution. As we are solving a real-world problem, and in many real-world problems, we don't have a master equation that we have to optimize. Instead of that, we have several realistic scenarios, several forms that the city can behave, and we have to optimize every of them. As we only have to apply one solution, we need a robust solution that make a very good performance in every one scenario. To achieve these two goals, we thought, well, forget very good solutions. The evolutionary algorithms perform very well, so why don't we use it? And also, as we need to get that the algorithm has robustness, we thought, why don't you use the iterated racing as they use IRACE tool to manage and improve the time and the efficiency of the algorithm.
Sí, sí.
Sorry. Okay. Well, sorry, someone turned on their microphone. So we ask, why don't you put together? So we propose a new hybridization to get the best of the evolutionary algorithm and the best with the elitist iterated racing as IRACE to solve the traffic light problems. Thus, as we use realistic scenarios, we also use a simulator to get the values for the fitness function. Now we represent the problems at the traffic schedule problem, and we just make an example to illustrate how that works. So we have a city, for example, this very little city. Then we have a set of intersections that they have 1, 2, 3 known traffic lights to manage the traffic. And every traffic line, each one traffic line, they have a time that they must be in red, a time that they must be in yellow, and a time that they must be in green. So we say that this is the program for one specific traffic light. Is we have the program of each traffic light on each intersection of the city. We have the whole program, traffic light program, for all the traffic lights of each intersection in the city. And this that we said is P. So this is our solution, a vector that they have the time that every one traffic light has to be in each phase in the city. And we have to minimize that fitness function. That fitness function have two special points that they was developed between the city council of Malaga and our group, and as we need to simulate it before to implement it, they have some restriction about the simulation that we put a maximum number of iteration of the simulation. So we could have vehicles that they not arrive to their destination. But this is a constraint of the use of the simulation in the fitness calculation. So after that fitness function, we not only have this level of realism, we want to make as realism as possible in order to get a very good solution for the city. So we use a real scenario. We use one part of the center part of the city of Malaga that I recommended to visit because it's lovely, especially in summer, in which we have a 3 kilometers square, 58 intersection, and 275 traffic lights that must to be scheduled to optimize the traffic in this area. With this map of this instance, we also have had sensorized data that allow us to get a different realistic flow of the vehicles. We have the origin and ends, and we are the path between them. With all of this information, we make 60 traffic scenarios, each of one with 4,827 vehicles, and we divide them in 2 sets. One for a training phase that we will explain after, and 30 for testing. Each one simulate a scenario, realistic scenario. We use it as an input for a sumo traffic simulator in order to get the information that we need for the fitness function, the traffic measures, that we have to use for the fitness function for optimize or the traffic schedule. We have in every execution and every algorithm, we perform a total of 30,000 execution of this simulation with different traffic schedules, plans, and different scenarios. So in this point, we know how the problem is, and we are going to explain the main part of the algorithm, not only with our algorithm, but also the parts of our hybrid algorithm. We have we mix 2 kinds of algorithms. From one way, we have a genetic algorithm with these parameters and a differential evolution. We also use this algorithm for the testing and check our proposal, but also are the components on our hybrid algorithm. In another way, another place, we have the elitist iterated racing. We base on IRACE tool. That this is a common tool to tuning algorithm, but also they perform good for search solution, numerical solution. The main goal of the main characteristics of the racing is that allow us to compare multiple scenarios and avoid wasting time in solution that is not good, is not promised. It's a very bad solution compared to the rest. So why expect more computational time in this? It's better to employ more computational time, more simulation in different scenarios in very good solution. So this solution will get more robust than the other. So we base on the pseudocode IRACE that mainly make a race phase with the solution that they have in the moment, and they update it and sample new ones. In this process of sample new ones, we use our evolutionary algorithms. We explained before better in the next slide. Yeah. How perform our hybrid algorithms? We sample initial population. We made the racing process. We simulate it. We run the execution, and we get the better one, the most promising solutions that perform the elite set. So now, iteratively, we get the elites, updated the set, sample new solution using the evolutionary operators. So the previous elites are the population of these algorithms. This may get new solutions that we mix with the elites to get a new racing that makes us a new elite, and iteratively, we will get the best solution from the elite set. So this is our hybrid algorithm. So in this point, we have all the components to explain our experimentation. We use the 30 realistic traffic scenarios for the training set, and we use the set input in our algorithm. We made two different hybrid algorithms, one that mix IRACE plus a DE and IRACE plus a GA, and also use as optimization algorithm IRACE and GA with the same parameters and a DE with the same parameters as the hybrid ones. We run the algorithm, that's in each iteration get new solutions that we tested with the traffic light program that is the solution, plus the scenario that correspond about the racing. We perform a simulation. We get the traffic measure that we calculate the fitness function and again and again and again until we have the better one. These better ones is rerun in a testing set of 30 traffic scenarios. And we get the metrics, and we get from them the best traffic light program for our experimentation. As the first result, we are focusing the training set. So we can see the mean fitness in the each elite set in each iteration of the algorithm. We call the evaluation because one evaluation is for the algorithm, but it's not okay. So we can see that the very fast the algorithm that's based on IRACE, this IRACE and our hybrid, perform very well compared to the evolutionary algorithms. Specifically, if we focus in this area, the orange area, we can see that the best solution is IRACE plus DE. So we can see that our proposal is very promising in order to get a very good fitness value. But however, this is in the training phase, and we have to get the better one in the end and run with the testing scenarios. So in this graph, we can see for each algorithm, and this IRACE, the hybrid algorithms, D and GA, the fitness values. Each box plot corresponds to the execute of one single solution in each one of the 30 testing scenarios. So the first box plot is one solution in 30 scenarios. The second box plot is one solution, is the second solution in the 30 scenario, etc. So we can see that in general, the hybrid algorithms are very, very good, more robust, have a little variation than the evolutionary algorithms. And you can see that there is also very good in optimality. They have lower fitness values than the evolutionary algorithms. If we make a big picture and we saw some statistics, we see that the mean and median value are they have for the IRACE have the winners of these two statistics, and in standard deviation is mainly the same as another hybrid and IRACE. I know that they seem so similar, but I'm sure that they have significant differences. In the paper, you can see the tables. We perform a Wilkinson on some rat text, and they have a p-value less than 0.05. Well, we also, as we are testing in we are solving a real world problem, so we have to know if the city has a real improve, which win an algorithm. So we can see that the values of the median fitness in each one of the metrics that Sumo returned to us in the simulation. This is the thing that not penalized because we rerun the execution of the algorithm in the testing scenarios without make a maximum time for the simulation. So we wait to each car arrives to the destination. So we can see that in general, IRACE plus D is the best one. And in the worst case, that is maximal travel time, maximum waiting time, there was the IRACE plus G, the most robust and also the best one in medium. So we thought that the hybrid algorithms perform really well for this kind of problem. So in conclusion, we propose new hybrid algorithms combining IRACE with two evolutionary algorithms. We use it to solve the traffic light schedule problem in the city of Malaga. Use also a simulation. We compare with the components of these hybrid algorithms, they are IRACE, GA, and ADE. Both hybrid algorithms perform better than the evolutionary algorithms, and even that 60 times of the time and 70 times of the time, and even than IRACE. And also, we improve the city not only in the traffic way, but also reduce time, fuel, and CO2. So in the future work, we would like to add this algorithm to a tool that we perform in the group that is in property of the city hall in order to better improve the traffic light of the city of Malaga. We also want to try different evolutionary algorithm, evolutionary operation, and also we test another sets or explore more deeply the behavior of IRACE. And finally, we would like to test not only real world problems, but also black box numerical optimization problems because we thought that maybe this algorithm will perform well for this kind of problems. So I hope that you enjoy that presentation. Thank you for your attention. And if you have any question, my pleasure to answer it.
Okay. Thank you very much, Christian, for this very interesting talk. And are there any questions? Okay. Let me start with one question about your data set.
Okay.
So you said it's a real world data set, which was provided by the city of Malaga, right? So what kind of...
No, please continue.
So I was wondering what kind of fluctuations in the traffic that actually included. So was it just the time of the day, or was it also different days of the week? Was it different seasons? Because I guess you have more tourists in summer, since you mentioned tourists.
Yeah, I know. Yes, the traffic is about we got the data with the traffic sensors in Malaga, and we have a lot of I don't remember, but maybe it's a couple of weeks or to get a picture, a general picture, if every time of the day, every day of the week, and every hour of the day, more or less. But it was generated in order to get general waves. We focus in more working times and then return to the house, and some of the weekends we use a tool that they use this information to generate the traffic flows in a more realistic way. I can get you the bibliography of the tool that they was made for a coworker, so I can get you the tool.
I think it's quite impressive to have this realistic data set. Would be interesting to see if you can achieve similar improvements in other cities, maybe that have a different setup also.
Yes.
Okay.
We hope so.
Good luck. Really interesting. Okay. Any other questions? Milan, I see is raising their hand.
Yes, thank you. First of all, thank you for the presentation. Really interesting and also really inspiring. So I was wondering if I understood it correctly, you would, if that would be a real world application, you would use the outputs, the optimized traffic signals, like in a passive manner. So this would just run for a period of time, or is it something that you would optimize in real time based on real time traffic data? Or does that make sense, my question?
Yeah, there was a legal problem in Malaga that the manager of the traffic, they don't want to modify the traffic lights in real time. Okay. This is legal. Yes, they told us they test some automatical traffic light, but they don't like it. So this is a previous stage. We made a planning from the data. If we perform in our tool, we just spend 1 hour, I don't remember, but more or less like that. The simulation is very fast in this scenario, and in the Malaga is not too much. So just one day the traffic managers, it's okay for them because they don't need just arrive the real time. They don't want it.
Okay, I see. Yeah, that makes sense. Thank you so much. Yeah.